Welcome to BVS Pragati channel. In this session, let's have a look at shift registers, and as part of shift registers, we'll look at parallel in, series out shift register, and also we'll take a look at parallel in, parallel out shift register. So here it is a 3-bit shift register. It is employing D flip-flop. So what is the operation of D flip-flop? When the clock goes high, whatever be the value of D, that is appears at Q1. Okay. So if this is 0, Q will be 0. If this is high, it will be high. Now, in this, to input the data parallelly and to output the data serially, we are employing a logic. Let's have a look at the logic. So, when the control line goes high, let's say that when the control line goes high, it is used to output the data serially. When the control line goes low, it is used to input the data parallelly. So let's say that the control line has gone low. Okay, when this goes 0, what happens? The output of NOT gate becomes high. When the output of NOT gate becomes high, this is one of the input to all the AND gates A2. So the output of the data bits, all the AND gates A2 become enabled, and the data bits are available at the output of AND gate. So B2 is available at the AND gate of A2, the output of AND gate A2, and this is in turn available at the output of OR gate O1, which is the input to D2. Similarly, B3, which is the output of AND gate A2, is now available at the output of OR gate O2, and this is now the input to D3. So B3 is available at D3. Okay, B1 is available at D1. Now when the clock goes high, what happens? Q1 is equal to B1, Q2 becomes B2, Q2 becomes B2, and Q3 becomes B3. Okay, that is how the data is shifted parallelly. And you see that the output is available parallelly at the same clock. So this is parallel out operation. So parallel in, parallel out. Now for series out operation, what we have to do? We have to make this control line high. When this control line goes high, output of NOT gate becomes 0. All the AND gates A2 are disabled and all the AND gates A1 are enabled. And the other input to A1 is the previous the output of previous flip-flop. So this Qn minus 1. So the previous state of this is the input to A1. So this is now available at output of A1, which is in turn available at output of O1, which is now the input to D2. So similarly for D3, the previous state of Q2 is available as input. Okay. So what happens when clock goes high? The values are available at respective outputs. Okay. So now Q1 will be 0, Q2 will be the previous value of Q1, which is B1, Q3 will be the previous value of Q2, which is B2. Similarly, at time instant C, what happens? The 0 over here is shifted to Q2. The 0 over here, the B1 over here is shifted to Q3. So it is 0, 0, B1. At time instant D, what happens? The B1 is moved out. 0 is shifted to Q3, 0 is shifted to Q2, and 0 is shifted to Q1, and becomes 0, 0, 0. Okay. Now let's have a look at the timing diagram. Here is the timing diagram. Now at time instant A, what we are doing? We are making the control line go low. So at this instant, we are trying to input the data parallelly. So when the control line goes low, what happens? All the AND gates A2 become enabled and A1 become disabled. So the output, the data bits are now available as inputs to the flip-flop, and which is available at the output of respective flip-flop. So Q1 is equal to B1, Q2 is B2, Q3 is B3. So the word is B1, B2, B3. So the output is available parallelly at the same instance. Now at time instant B, what is happening? You are making this control line go high. So now all the AND gates A1 become enabled, A2 become disabled. Now the data is shifted towards the right parallelly. now the data is shifted towards the right serially. Okay, so the previous state of Q1 is now available as output of Q2. Previous state of Q2 is now available as output of Q3. So the word is 0, B1, B2. At time instant C, what happens? Previous state of Q1 is available as output of Q2. Previous state of Q2 is now available at output Q3, that is B1. So the word is 0, 0, B1. And at time instant D, what is happening? It is becoming 0, 0, 0. Okay, that is what is explained. So when control line goes low, what is happening? The data is shifted in parallelly. Okay, now when the control line, that is what is explained over here. At time instant A, control line goes low and the word is shifted in parallelly. So the output is B1, B2, B3, which is available at the same clock parallelly. So output is available at the same clock parallel. This is parallel in parallel. To shift data serially, what happens? We have to make the control line high. When the control line goes high, what happens? At time instant B, the word is Q1 is 0, Q2 is B1, Q3 is B2. At time instant C, Q1 is 0, Q2 is 0, Q3 is B1. And at time instant D, Q1 is 0, Q2 is 0 and Q3 is 0. So we have seen that the output is shifted serially. So that's all for this session. More in the next session. Thank you. Thanks a lot and I wish you all the best.